Hello, everyone. You are welcome to today's lesson. And in today's lesson, I have a simple task. And that task is to walk you through the solution to the team assignment on the binomial theory. So stick and stay with me. This is your usual Mr. Hackman, the maths facilitator of Omega Vacation Classes. Okay, so quickly, let me walk you through the solution. All right. So on top will be the questions which you can see in red and the solution in black. So each of the slides, that is how it will come. The questions will be on top, and the solution will be below in black. Okay, so quickly, and take note, I will address some of your concerns, especially the major ones, that came to bear in your various submissions. Okay, so as usual, when you read questions, we are supposed to make it a habit to underline the salient parts, if any, before we start presenting our solution. So the first question, question one, expand does there is nothing salient for us to underline. So straight away we go and write solution. Okay, then after that, what do? Because questions are numbered, our solutions must be numbered accordingly and appropriately, meaning precisely. So solution to question one. Then you extract whatever that you are given, whatever that you need to work on. You are provided with to work on. Okay, so giving, okay, this is what you were asked to expand. And I've told you can choose not to write giving, but this must be extracted. Take note of that. Okay, so let me go for my laser pointer. Okay, so this must be extracted. So either you ignore the giving and you write this, or you write giving this. But as I always say, I encourage you to write giving for you to know that this one has no inputs. It is just copy and paste. You extracted this information from the question. So your real input, your first input, will take equal to, which will be your first step. And because it's an expression, each step on the way must be introduced using what? The equal to. So you know you are dealing with binomial theory. I've told you that anytime you are giving a binomial to any power and you are asked to expand, okay, check the exponent. If the exponent is positive, you thank God. Okay, if it is positive and it's huge, okay, you use, what do you call it, the combination version of the binomial theory. If it is small and the question didn't ask you to use the binomial theory but just expand, you can equally use the Pascal triangle to get the coefficients as well. Okay, so like I advise you in class, if you can know the coefficients, okay, of any binomial expansion using the Pascal triangle up to the power 5, that will be fine. So this is power 5, so I know the coefficients, and the coefficients we know using the Pascal triangle, the coefficients will be 1, okay, 5, 10, okay, 10, okay, 5, 1. So that will be the coefficients. Okay, so once you have this at the back of your mind, you are more than good to go. So quickly, let's go and look at the solution here. So equal to, I know, okay, binomial theorem. If you want to quote it, I've told you, you can quote it. Okay, so I know that my first term will be of the binomial expansion, will be my term here, okay, the first term of the binomial, all to the power 5. So in each of the terms, my first term, or in the expansion, my first term, the power will start from 5 and reduce up to what? Up to 0, okay, from term to term. Then the second term, okay, of my binomial, its power will increase from 0 up towards the power of your binomial 5. So you know this is the coefficient that usually we have to use the combination to extract, or Pascal triangle, but I'm using the Pascal triangle. So in this case, I will get this to the power 1 over x to the power 5. Then my second term, you know, will be minus 2 root of x. So those of you who wrote 2 root of x, you know at this point you are doomed. Okay, we should be matured at this point, because the theorem is usually quoted in terms of plus. So if you write this one as 1 over s plus, then it will be minus 2 root of x. So if you compare, your b will rather be minus 2 and your a will be 1 over x. So if you go and substitute, this is what we are going to get. And the coefficients will come. You know that the first term, its coefficient will be 1, just as I've indicated here. But you can choose not to write it. then plus 5. Even this one, you can choose not to write it, but because you want to see the pattern, that's why, for explanation purposes, I have brought it there. I've told you any substitution that will give you the value to be 1, you can ignore, can choose not to write it. So 5, which is the next coefficient, then your 1 over s, the power reduced by 1, then your minus 2 root of x. You know your first step, the substitution must be in brackets and the powers must be outside. You know this advice. Okay, so now to play is safe. So to the power 1, then 10. So you do same. So 10, the exponent of your 1 over s will decrease by 1. Then the exponent of what? Minus 2 root of s will increase by 1. So if you do that, okay, your various substitution, this is what you are going to get. And here we are asked to give the full expansion. So you end at what? At the last term, which will be the 6th term. Then the next step, this will be equal to, remember, the next step is to push the powers in. The first step is to substitute, and if you substitute, your substitution must be in brackets, your powers outside. Okay, then the next step will be push your powers in. Those of you who use the combination, okay, to get the coefficients, yours will be, what do you call it? N combination 0, N combination 1. Okay, so not n, you know your n now, so it will be 5 combination 0, 5 combination 1, 5 combination 2, 5 combination 3, 5 combination 4, then 5 combination 5 as the coefficient. So for you, your next step, whilst pushing the powers in, you should also work on your combinations. Okay, the value of each combination that you have here to give you the coefficient. So take note of that. So if your solution is not presented this way, but you use the combination, you end up getting the same result. Only that before you quote the formula and come and get the coefficient, because I use the what do you call it, the Pascal triangle, I will get the coefficients. I've stated the coefficient straight away. But you will now come and get the coefficient when you are dealing with the combination value and what the power. So if you push the power in, this will give you 1 to the power 5, which is what? Which is 1. Then s to the power 5. You know, in indices, you should know this. Okay, just a quick reminder. In indices, if you have a over b all to the power m, okay, we know that this is equal to a to the power m over b to the power m. So that's the concept that was used here. So in the same way, you can see you have your a, which is 1 to the power 5. That will give you 1. S to the power 5 will give us s to the power 5. So what we have here? This we know to the power 0, any number to the power 0 is 1. So you can choose that. You can see that I didn't write it, simply understood to be there. Then those of you who want to write it, you can equally write it. Only that pair, the advice I've told you, if it's 1, you can choose not to. Okay, so now what do we have? The next one, it will be 5, 1 to the power 4, which is what? 1, then s to the power 4. Okay, so then you will get this one, which is minus 2 root of s to the power 1. And now if you push it inside, any number to the power 1 is a number itself. Okay, then 10, push the power in, that will give you 1 over s cubed. Okay, then this will give you minus 2 squared, okay, which will give you 4. Then root of x also squared, because again, you know from indices that if I have a, b all to the power m, okay, this is equal to a to the power m times b to the power m. Okay, so now what do we do with the same concept? Let me go and continue with my explanation. So at this point, okay, we are going to get, okay, minus 2 squared, which will give us 4. The root of s squared, the square will get rid of, so you get x. So you go and do same here. However, this one, the values will not be pretty. So let me quickly walk you through how I bought it. Okay, so now this one to give you coefficient is 10. Okay, then 1 over s squared, because if you push the power in, that's what you get for this particular factor. If you come here to, you are going to get negative 2 cube, and negative 2 cube will give you negative 8. Then you are going to get root of x cube. And take note, let me quickly write this. Okay, I'm explaining how I got what I have there. Okay, so I showed maturity, sorry. Okay, I showed maturity in my presentation. So if you have, take note, we said we have root of x all cube. Okay, so that will be equal to, you know, root of x is the same as x to the power half. Okay, so all cube. And you know in indices, if I have a to the power m, the whole of that, that's the power rule, the whole of that to the power n. This will be equal to a, then I come and multiply the exponent, so it will be m times n. So with this one, to the exponent here is half, then the whole of that, the overall exponent will be 3. So it will be half times 3, which give me 3 on 2. So that is exactly what you have here. Okay, just as you can see there. So I guess my point is well made there, and that is what I'm going to use, okay, for the other terms as well. So this will give me 5. Okay, any number to the power 1 is the number itself, so 1 over x. So if I push the power in, that's what I will get. And this will give you minus 2 to the power 4. So any number, any negative number to even power will give us a positive result. So it will give us positive 16. Then here you are going to get root of x to the power 4. So that will give you in the same way. That will give you, let me see if I can write for you to follow, okay, clearly. So that will give you root of, we said, it will give us root of x is the same as x to the power half. So x to the power half all to the power 4. So if you multiply it, you are going to get, okay, half times 4. So it will be s to the power half times 4. So the 2 will go here. So that will give you s squared. So that's how come I have s squared here. And that equally explains the last term. Okay, so the coefficient will be 1. Any number to the power 0, okay, will give us what? 1 as, yes, 1. So I decided not to write it. Then now you come and do minus 2 to the power 5, and that will give you minus 32. Any negative number to odd power will give you a negative result. Then this will also give us x to the power half all times, okay, all to the power 5. So that will give you x to the power 5 on 2. So that gave me what I have here. So my next step, okay, is to simplify or remove the final set of brackets that I have in each term. So that will give me this. If I remove the bracket, I'm going to get this. This, if I remove the bracket, it will be minus 5 times minus 2. That will give me minus 10. Then my x, okay, is going to give me root of x over s to the power 4. And let me show you how I got what I have here. So let me clear this and explain that, so that those of you who are not able to relate, okay, and couldn't deal with it from your submissions, okay, you now appreciate, okay, the concept behind that. So it's indices that we are making use here. So that's why I always say that in math, whatever that you learn, you don't throw it away, you will need it. Okay, we are doing binomial theory, but you can see that we are dealing with what? Application of indices as well. Okay, so at this point, what do you do? So this is what I did to get this particular value that I have here. Okay, for my, so in this case, I am going to get, remember, that will give me root of x. So I'm dealing with my x, okay, over what? S to the power 4. Okay, so we know that this is the same as what? Root of x is the same as s to the power half. Okay, all over s to the power 4. And you know, as one of the rules of indices, if I have a, okay, to the power m all over b to the power n, so let me use a, the same base to the power n, sorry. This will be equal to a to the power, your numerator exponent minus your denominator exponent. You know this. So that's what I did. So my numerator, so this will give me s to the power half, okay, minus what? 4. So half minus 4 will give you minus 3, okay, and half, okay, which will give you, okay, 7 over 2. So I had s to the power 7 over 2. Okay, so that will give you, if you do it, you get s to the power minus 7 over 2. Okay, so those of you would want to keep it, okay, your the exponent of your s as negative, then this is what you are supposed to get. Okay, with this one, as if you want to bring it up, okay, then this is what you are supposed to get. So that's why you can see the order. Okay, so take note of that. Okay, so because I know 1 over a to the power m, okay, that is equal to a to the power negative m. Anytime you bring a base up, okay, its exponent must be negated. Okay, when it becomes a numerator, a denominator base, if it becomes a numerator base, then the power or exponent must be negated. So take note, that's a concept that I use. So that explains also what I have here. Okay, so this will give you 40, then you get, as for this one, you know the x will go into one of the x here. So if you left it, okay, 2x here, so that will give you x squared. If you want to bring your exponent up, I mean your base up, in that case, it will give you 40x to the power negative 2, and that's what we have here. Once you bring this your base up, the exponent must be negated, like I said. Then same for this one, explanation. So you should be able to do. So this one too, we are going to get 10 times negative 8, which will give us negative 80. Then you get x to the power 3 on 2 all over s squared. So that will give you s to the power 3 on 2 minus, okay, 2. So that will give you, so 1.5 minus what? Minus, what do you call it? 2. Okay, will give you minus half. So it will be s to the power minus half, or, okay, if you bring this one, the s to be a denominator base, then the exponent must be positive. If it was a denominator base and you bring it up, it must be negative. Okay, and that explains, okay, I mean, whatever that I've said, if you are able to relate, you should be able to deal with the other two terms that we have there. Okay, so it's either you conclude with this, okay, where your base will have, your base will be x and the exponent will be positive, or you can take it, okay, up where your basis will be a numerator base and the exponent will be negative. So that explains the other or the answer that you have here. So I believe my point is well made. If you have any issues when you watch, okay, my video on my YouTube channel, please don't forget to, okay, ask all the necessary questions, okay, there, okay, and pass all the necessary comments. Okay, so that will be it for question number 1. Now let's go and look at question number 2 quickly. Okay, expand, we are supposed to expand this in ascending powers. So we underline ascending powers of x up to and including the term in s cubed. So these are the critical, okay, parts of what the question that we need to underline to guide us as to how our expansion is supposed to be done, or the nature of our expansion, okay, and also the point that we are supposed to terminate or end our expansion. So as usual, okay, given, you extract whatever that you are giving, okay, there. So that is what we have here. Then what do we do? Once you have it, okay, this must be maintained. So your first step equal to this maintain down. It is this that you can expand. And here, like I said, I advise you, and I equally took that advice, that you can use what you can memorize, okay, either consciously or unconsciously, the Pascal triangle coefficients with the power 1 or maybe 2 up to 5, but this one has gone beyond that. So it means I'm going to use my combination to easily get the coefficient. Okay, so it will, and you know, if you are quoting the what do you call it, the combination one, you don't quote what the a plus b to the power n1. You quote the 1 plus x because there's a special case of what the combination what formula for the binomial theorem. So in this case, I will get 1 plus 7 combination 1. Then you know it should have been, I didn't quote it, I quoted it mentally. So it will be 1 plus, if you use the 1 plus s to the power n, if you, the theorem will give us 1 plus n combination 1x plus n combination 2s squared. If you compare, you see that your n is 7, then your new x is 2x. So that's what, so it will be 7 combination 1. My x is now 2x to the power 1 plus 7 combination 2. My x is 2x, okay, squared, plus 7 combination 3. My x is 2x cubed. Then here I end there because of the nature of the question up to the term in s cubed, so plus ellipsis. Okay, so at this point, my next step, I will write this again just to keep the equal to, then come and deal. You can see that you have a square bracket, and I put a square bracket there because by experience, you will know that your first one, there will be substitution, and that must be in bracket. There will be a bracket inside the bracket, so the outer bracket should be the square bracket. Okay, that was just by the way, I believe you know. Okay, repetition is basically for emphasis. Then, what do? This will be 1. You come and deal with the combination and push the powers in. So 7 combination 1 will give you 7. 2s to the power 1, if you push it inside, you get 2s, plus 7 combination 2, 21. 2x all squared will give us 2 squared, which is 4, then s squared. Then 7 combination 3 will give us 35. 2x cubed will give us, okay, x cubed, that 2 cube will give you 8, then what? S cube.